All right, yesterday we learned how to do some polar graphs using tables of values in our calculators. Today we're going to learn how to do polar graphs using kind of the shortcut methods of knowing some basic shapes and kind of just using the facts in our problem to kind of outline the shape that we know it's going to be. Picking points, kind of doing this by hand. All right, so first problem in day 2 of the polar graphs, we're going to try problem number 22. And in your book, there's a series of pictures from some patterns we've explored with our, earlier pictures, plus a few more. And so all we have to do is take this formula sheet, which I put together for you, basically photocopying out of the book. Plus, I added a couple for you here. If we put these together, basically what we're trying to do is match up which type of equation is 4 sine of 3 theta. Okay, so these have r squared, it's not those. It looks like it right down here. So we're going to get a 3-leaved rose where the a value is 4 in our case, which means our rose petals are going to go out to 4 on those angles. Okay, so now we know what the general shape is. We just have to pick a couple of points to make it happen and make it look nice. Okay? So, let's grab a piece of paper here. Alright. So we know what it's going to be like. Just let's figure out where we are. 0. If we plug in 0, 3 times 0 is 0. Sine of 0 is 0. Times 4 is 0. So at 0, we start at 0. And just like this piece of paper said, at 30 degrees, we're going to get to our peak. So at 0, we're going to then go out, get to our peak at 30 degrees. Because 3 times 30 is 90, sine of 90 is 1, which is its largest value, and 4 times 1 is 4. So at 30 degrees here, we're going to be out at 1, 2, 3, 4. And so between 0 and 30, we have to curl up to the top of that leaf. Okay? Alright, then we're going to come back. Question is, when do we come back by? Because I don't want to cross over any line. I want to make sure I get back to 0 at the right spot. Let's try plugging in 60. 3 times 60 is 180. Sine of 180 is 0. And 4 times 0 is 0. So by 60, we should finish this leaf. So you don't want to cross over 60 going this way. You got to finish that leaf and get to 0 at 60. Okay? Then we know that at 90, 3 90s is 270. Sine of 270 is -1. And so when we're facing 90 degrees, so we're here facing up, we actually go 4 times -1 or -4, which is backwards. 1, 2, 3, 4. So we get to the bottom of our graph at 90 degrees, actually. So between 60, which extends back to here, we got to make sure our leaf stays on that side of that line. And we get to this bottom leaf. Okay. So if you notice, every leaf is contained within 30 degrees here. So we have to bring it back in by the next 30 degrees. Okay, so that would be 120. And then at 150, we're going to get our next peak. So staying between 120 and 150 here. 1, 2, 3, 4. We're going to get to that peak of that rose petal. And then by 180, we're done. Now, if we kept going, we would just circulate this picture again. All right, so that's the first example. Second example I want to do with you is number 28. X squared plus y squared is equal to x squared minus y squared. It wants to do 2 things, graph and convert, or specifically convert and then graph. If you could graph first, I'd have no problem with you doing that. But in this case, I want to make sure that you convert first, because I have no idea what that graph looks like. So let's convert. We know that r squared is equal to x squared plus y squared. X is equal to r cosine of theta. Y is equal to r sine of theta. Okay. So therefore, we can take this out, put an r squared in there. We get r squared squared. And then in here, we can take this plug it in for x, and get r cosine of theta quantity squared. Take that, plug it in for y, get minus r sine of theta quantity squared. Okay, this gives us r to the fourth equals, here you're okay because there's no plus sign in there to square each item, r squared cosine squared, and then minus r squared sine squared. Okay, now if we factor an r squared out, we get this nice thing, cosine squared of theta minus sine squared of theta. And we can go ahead and divide it by r squared. Now, if you look at the picture, at the sheet, none of these match up with that formula. But, it's good news, we've done some stuff before. We should recognize this form as from one of our identities. That is the same thing as cosine of 2 theta. Okay? So, we get what's called a lemniscate, or a two-leaved rose. Okay, it's going to go horizontally like this, and it gets out to the square root of a. What's the a in our value, in our problem? 1. So we're going to go out to 1, and then come back in. Make like a little infinity sign. So now once we've matched it up, we can easily make that graph. I don't think I want to keep it in here, so I'm going to change my scale. I just go, we'll make that a half, and then this is a 1. Okay, so at 0 we're at 1. The question that I would have is when do we get back into the origin? So, but it sure looks like it's coming in at like 45 degrees. So let's test that. At 45 degrees times 2 is 90 degrees. Cosine of 90 is 0. So sure enough, at 45, I get my rose petal done. So something like that. Doesn't have to be perfect. Maybe it should be more rounded. Okay. Now from 45 to 90, what the heck happens? Well, if you take like 90 and plug it in, cosine of, well, 2 90s is 180. Cosine of 180 is negative 1. So at 90, we're actually at negative 1. But r squared equaling negative 1 is an impossible thing. So we actually have a domain issue. So nothing's actually happening in there. Okay? So after that, we can carve out the next petal over here at the 135. So then we start going like this. Wait, 1, 2, 3, 4. Okay, so over here we get. I think I just make sure we don't go past the 45s. That's terrible. You get the idea. Just has to have the right qualities. Okay. Let's go on. Try to get 1 or 2 more done. Number 32 is r times quantity 1 minus sine of theta equals 1. And it's our job to again convert and graph. This is the one that they don't want us to graph from this form because none of these equations look like that. So instead what they want us to do is to convert to rectangular, and then we must recognize what it looks like in rectangular and graph it from what we know from advanced algebra. So by distributing here, we get r minus r sine of theta equals 1. This right here, based on our equations up here, r sine of theta is y. So we're going to write a y there instead. And this thing is kind of unfortunate. If I take the square root of both sides, I can get r is equal to plus or minus the square root of x squared plus y squared. So it looks really yucky, but I can convert an r into x's and y's. So that's what we have to do here. Okay, so let's add the y over so we can clean this up a little. and then square both sides because I don't recognize that, so let's try to clean it up some more. Squaring here, it doesn't matter if it's plus or minus, will become a plus, and we'll get x squared plus y squared. And squaring here, you have to remember to do a y plus 1 and a second y plus 1 and FOIL this out. If you do that, you get y squared plus 2y plus 1. First thing squared, twice the product, second thing squared. Subtracting y squared from both sides works out really nice for us. Okay, and now you should start seeing this is an x squared, the y is not squared, so this is a parabola. Generally, we'd like the non-squared thing solved for, so let's subtract the 1 divided by the 2, so we get x squared minus 1 is equal to 2y, or we get the equation y equals 1/2 x squared minus 1/2. This is a parabola. It is a parabola where it opens up wider and it's shifted down 1/2. So we could do that really quickly. So there's -1, so its parabola is now shifted down 1/2. And then every time I go over, normally we go over 1 up 1, but because of this multiplier, we go over 1 up 1/2. We get points here and here. And then normally from there we go over 1 up 3. Now we go over 1 up 3/2. 1, 2, 3. And if I go by halves, it's 3 marks. And we'd get our parabola. Alright, I hope that helps, and you can always use your Chromebooks to watch parts of that video again. Good luck. Thank you very much.